Now, while we're on the subject of extending the platform, we're going to go through some really cool capabilities that take us through extending both desktop and server. And so to walk us through that, I'd like to welcome back to the stage Jim.
Thanks, Dave. Hey, everyone. So, as Dave said, here's a section that's really, really important, and it's extending and automating ArcGIS. And I'm going to start with ArcObjects. I'm betting that if you've done development against ArcGIS for quite some time, you have used ArcObjects. And you have a very deep investment in using ArcObjects, either creating extensions for ArcMap, building add-ins, creating server object extensions. And I also want to assure you that that investment is sound and will remain sound for a very long time. We just shipped 10.4 a few weeks ago, and we internally did so much work. Lots of folks in Redlands, really the whole dev team, we touched ArcObjects to upgrade it, to optimize it, to improve the quality. We upgraded the internal compiler. And we're also supporting, for you as developers, Visual Studio 2013, 2015, and finally, we've got .NET 4.5 in there for you to develop against. And you can clap on that one. You know, and we want to do a better job of supporting ArcObjects with the latest IDEs going forward, and we will do that. All of the resources for ArcObjects we've also put on GitHub at the URL there. So pull those down, contribute to that community. So we've moved those resources in there. And also, if you're extending ArcGIS server using .NET or Java, building SOEs or SOIs, we're supporting the latest version of Eclipse, and we're continuing to go forward there, making sure that that is absolutely sound for the foreseeable future. We're really excited about that. Now, this morning, we looked at driving ArcGIS using Python from a platform perspective, and that was pretty awesome. But as all of you know, you can also use Python to automate and build awesome GP tools with local aspects of the ArcGIS platform, individual products. And we're going to talk about Python and ArcGIS in a really cool sense, and we have a really interesting announcement to make as well. So I'd like to introduce Bill and Clinton to walk us through that. Take it away, guys.
Thank you, Jim. Hi. I bet most of you, when Jim just mentioned Python, was thinking, oh, a scripting language. Come on, admit it. But let me assure you, Python is a very powerful programming language used to extend and automate ArcGIS. It is not only used to string together high-level geoprocessing tools, but can work with the fine-grained capabilities of ArcGIS using Esri's ArcPy module. Python is the best programming language for extending ArcGIS desktop and server by building geoprocessing tools, as they just work across the platform. It's as simple as that. We ourselves ship almost 100 tools written in Python for that very reason. For those of you who are currently building geoprocessing tools or going to build geoprocessing tools, we have been strongly recommending for many, many years to use Python more and ArcObjects less. Christopher Moravec, Director of Software Development for G2 Integrated Solutions, took that advice, and by using Python, they only had to build their tools once, and it not only worked across the platform, but across all versions, without having to advance the slides. Thank you, Jim. Without having to recompile. I want to repeat that. They didn't have to recompile their tools to have them work across the platform and across the versions. As a developer, thank you, Jim. As a developer, Christopher's words on porting to Pro sums up why to use Python. He said, our Python tools just worked. We are ready to support Pro, and the application was not even out. we are ahead of our users. My team is here. Please take time to visit with us throughout the summit. We want to work with you to make sure ArcPy provides the functionality you need to be successful. One of the active dev projects for 2016 is integrating Conda with ArcGIS, which will make the using of Python modules easier than ever. To show us how Conda can make the building and deploying of your tools simple and stress-free, here's Clinton Dow.
Thanks, Bill. As was mentioned, Conda gives you the power to extend the ArcGIS platform with all of the open source code that's hosted on the Python package index. If you've used any of these packages before, you know that they have varied installation requirements, and sometimes the installations don't go as planned. So we're implementing Continuum Analytics Conda in the ArcGIS platform to allow you to have access to everything located on the Python package index. Also, your ArcGIS, or your Python 2.7 tools will work in ArcGIS Pro. Conda is a forward-thinking Python package and virtual environment manager, and it takes the guesswork out of everything package-related. This means that it'll allow you to share tools across and within organizations very easily. To illustrate this, let's jump over to ArcGIS Pro and take a quick look. So what I'd like to do here is run a tool which imports a third-party Python package. In this case, it's the Python Spatial Analysis Library, or PySal, which is provided from the Geoda Center at ASU. Now, I don't currently have PySal installed on my laptop, so let's jump over to the command line and install it using Conda. If I run Conda, it takes care of installing the package for me. It finds the dependencies, compiles them, and installs them right into our Python environment. Jumping back into ArcGIS Pro, oh, and I should mention that in ArcGIS Pro, we are going to implement a UI element which emulates the NuGet package manager in Visual Studio and will allow you to do all of this within the app. Now that we're back here with PySal installed, I can just click Run, and the tool will just work. It's that easy. So, as we see now, we have all of the functionality from the Python ecosystem available within ArcGIS Pro. Now, this is currently a work in progress, so if you do have any comments or thoughts on the matter, please feel free to stop by the Python Island over the course of the week and give us any thoughts that you have on the matter. Thanks very much. Back to you, Jim.
Thanks, guys.
Thanks for moving my slides around.
I didn't touch, man. It's easier to import thousands of Python modules than advancing a PowerPoint slide in a plenary. That's what that demo was all about. So, we've seen ArcGIS Pro as a great new desktop application a lot this morning, and we've seen it supporting visualization, we've seen it supporting analysis, and we've seen it supporting sharing information across ArcGIS. But you, as developers, really care about the SDK for ArcGIS Pro. We were able to ship the first version of the SDK with the 1.1 release last year. We've done some really great work with the 1.2 release, and this week is a great week for you to give us input about what we should be building for you to support your important workflows using the Pro SDK. And in order to take us through some of those new capabilities with 1.2, I'd like to introduce Charlie MacLeod, who leads the ArcGIS Pro SDK team, to share with us that information. Take it away, Charlie.
Yeah, thanks, Jim. So ArcGIS Pro is a modern, multi-threaded 64-bit application. And I'm going to show you how to extend Pro using two .NET add-ins written with the ArcGIS Pro SDK for .NET. Both these demos are going to look at an increasingly popular technology for GIS called geotagging. So in demo one, I have here the GIS application, which synchronizes pipe inspection videos with the corresponding pipe features on the map for visual pipe infrastructure assessment. It's prototyped with the SDK by our partner, Geocom Informatic, Switzerland. So on the map, I'm showing a subset of the GIS sewer pipe infrastructure data. And when I select the pipe feature on the map, its corresponding video is selected from the database and then loaded into the viewer. The red dot on the map shows the starting location of the video. So I start playing the video. The video is playing. The camera hasn't started moving yet. So I can skip forward. OK, so now the camera's moving. We see its position synchronized on the map. And I got other standard controls. I can skip forward, back, pause, play. I can seek the position here on this little slider. OK. Perhaps more interestingly, I can select the position on the pipe, position the video. I can drag the position of the video on the pipe. OK, let's take a look at the code. All right, so on the left, I have the metadata that GIS uses to synchronize the video with the map. It is an ASCII file which contains a set of segments, and each segment has a starting and ending time, as well as the corresponding position on the pipe. Now, even though GIS is using a custom format, we could use any number of standard metadata formats for synchronizing video and media with Pro, GPX, NMEA, and so forth. So we matched the playing time of the video with the corresponding segment that we read from the metadata file. Because we know the speed of the camera, it's 10 centimeters per second, we can interpolate the distance on the pipe to within 10 centimeters. Here, we're doing the reverse. We're taking a distance from the map. Once again, we find the corresponding segment read from the metadata file, and then we convert that distance back to a time to set the position of the video. Okay. And there are plenty of other possible applications for synchronizing video with Pro, video from other sensors. But the principle is basically the same as I'm showing with GIS. That's all possible with Pro and the SDK. All right, I'm just going to go ahead and stop this. Let's move on to demo 2. Okay, so sticking with the theme of geotagged media. So this is a simple application we've written with the SDK. And let's say you want to view the street view for some set of locations. So here's a map tool also written with the SDK. And when I click the position on the map, we pass that point to Microsoft's Bing Street Side to show the corresponding street side view. Now, I mean, there are many third-party technologies out there that all use, that provide geotagged media that you can leverage. They're all driven by location. In this case, we're just using Bing. Now, you want to be able to synchronize the apps in both directions. So I can click on the street side view, and I can update the position on the map. I can link Pro with Bing. So I manipulate Bing. I can manipulate the map. Let's take a look at the code. So here we're handling the mouse down click on the map. A couple things to notice. First, this async suffix return type task. It's an asynchronous method. And we're running it on the background thread of Pro. So we take the point clicked on the map. We convert it to a lat long. And then if we can connect to Bing, we pass it that XY to show the corresponding street side view. Then we place the point on the map, and then we zoom and center it. Okay, so coming back the other way, we're taking the position here from the street side view. Again, it's an asynchronous method, suffix async, a return type task. This time, we're converting the lat long from Bing back to a map point. And then once again, we show it on the map and center it. And maybe, for some reason, I'm interested in this location, so I want to flag it. Perhaps I want to hand it off to Field Inspector. And we have lots of great apps we're going to show you to help field inspectors, whether it's to route some set of locations that you're collecting, or to collect more data in the field and so forth. And that's it. These are just a few of the exciting new ways we can use the SDK to integrate ArcGIS Pro with your organization's workflows at 1.2. Thanks, Jim.
Thanks, Charlie. It's cool. So if you want to build an add-in for Pro, extend the user interface of Pro, integrate with external viewers or apps, basically all of you have your own workflows, and you need to integrate with many systems. And the SDK actually walks you through that. So the next thing we'd like to talk about is extending the ArcGIS platform from a server perspective. Many of you have invested a lot of work in building server object extensions. Last year, the server team shipped the capability of building server object interceptors, and that work has just continued to get better and better and better. And for some exciting new capabilities with that work, I'd like to introduce Jay and Tanu. Take it away.
Thank you, Jim.
Sure.
So over the next few minutes, we're going to talk about server object interceptors as a specific way to extend the platform. There are a few other ways also, like server object extensions and GP tools. But we'll focus on this. So the platform starts with your WebGIS that you see in the middle. How you extend using an interceptor is very similar to how you extend using extensions. As a programmer, you'll write your program in Java or C#, and then the administrator will deploy it on your WebGIS. And then the publisher will choose on a specific service-by-service basis whether to exploit this feature or not. And what you get at the end of it is actually an extended GeoServices API that is actually exactly the same as far as the client applications are concerned and the APIs are concerned. All that you changed is the behavior behind the scenes. So you preserve the API in all cases. So that's pretty powerful. And the way it works is very simple. All that you're doing in your program is you're pre-processing the request, and you get a capability to post-process the response. And what's new in the upcoming, in the release that just came out last month, the 10.4 release, is that you can chain these SOIs together. So developers and business partners like you can complement the functionality on the same service, and so you can build rich server-side applications based on this. So for the demo today, here's what my use case looks like. I have asset data, which is basically stream gauges located along creeks and rivers. And on another table, I have observation data that's recording the water levels of each of these stream gauges over an extended time period, like you can see here. So what I need to do is pull together some things on the server side that are not readily available, because I don't have a time-enabled layer, and so I don't have a time-enabled map. And as an analyst, I'm interested in some end functionality. So I need to do a few things. I need to join these things together, and I need to bring them all together in a form that makes sense to me as an analyst, which is I want to aggregate some fields on the fly based on some random time periods that I specify. So how do I really do this and get what I would call a rewindable map? So in order to do that, I'm going to ask Tanu to help us through with a demo and showcase how you can use an SOI and build functionality like this. Tanu.
Thanks, Jay. As the time slider located below the map is stepping through time, the 7-day average water level is getting computed on the fly for each time step for each stream gauge. The layer is using that on-the-fly computed average water level and draw those features using a proportional renderer. The source of the layer is a dynamic map service layer that is powered by an SOI. The SOI augments both outgoing layer and feature resources. It includes full time extent to the map resources for all the observations, even though neither the layer nor the map was time-aware in that original map document. It also appends 3 virtual aggregated fields in the layer resources. The SOI modifies the incoming request based on user inputs. By choosing the average water level field and picking a times from the time slider, it instructs the map service to draw all those stream gauges using dynamically computed, I repeat, dynamically computed average water level for the current map extent and the time extent. Clicking on the feature further instruct the map service to compute maximum and the minimum water level in addition to average water level. The time can be changed dynamically. For long-time analysis, it could be 10 days. For flash flood analysis, it could be just an hour or 15 minutes interval. The way SOI does it, it's by intercepting all draw and query requests and modify that query that goes to the database. In this case, it's just a join query between asset and observation table with one or more aggregated fields. And it performs really good for a table with not only 10,000, not 100,000, not even 1 million records. It's just more than 5 million records. What do you think, Jay?
That's exactly what I was looking for as an analyst. That makes sense. Now, I still want to preserve the functionality, the lesser functionality that is available to a viewer who can just look at the latest observations and not the analyst who can rewind, right? So with chaining SOIs, I'm assuming you can stack on a security SOI on top of this.
Yes. So if I look into that capability page on ArcGIS Manager, you see I chained a role-based access SOI with my functional SOI. Let me show you how it works. So this time I'm logged back in as a user with limited privilege. The first thing you notice is that there are no time slider at the bottom of the screen. In that context menu, there is no option to bring that time slider back up either. And if I go to the change style page, in the drop-down box, you don't see those virtual aggregated fields anymore. What that means, the user right now can only view those stream gauges with current water level.
That's great. That's exactly what I was looking for. But this is a Dev Summit audience, OK?
Right.
You never brought up an IDE. Can you just set the debugger, step through code, show us it's real?
Sure. Let me enable my breakpoints. I'll refresh the map a little bit. And you see it gets intercepted by the SOI. And you see the user identity gets flown through. And SOI sets some parameter based on it. And if I continues, it goes to the next SOI in chain.
Now you can relate to that, right? So this is how you build an SOI. And in conclusion, what I would say is that what you saw in the demo was two things. One is it was a single service that manifested itself in two different ways, an operational map for the viewer. And if you're an analyst, which is an escalated privilege, you are now then able to see a rewindable map with aggregated values computed on the fly. And this is all possible because of SOI chaining. So thank you very much. Hope you find this as a useful feature. Back to you, Ewan.
Thank you, Jay. Thank you, Tanu. Server object interceptors. As a client developer, they're fantastic because none of my code has to change in order to consume the enhancements on the server.